Well, we're in the final session here, just a couple sessions left, and our final keynote is someone who you met yesterday, and the person that, as you all heard, was there at the very beginning as chairman of the board for AMT. Now he's on the MTConnect Institute Board of Directors, and a very key driver in all things MTConnect. So I'd like everyone to please give a warm welcome to Doug Woods.
All right, folks. Boy, you guys are fantastic gluttons for punishment, hanging around here to the end. I appreciate that, especially the people in the back row I paid to actually stay to fill up the room a little bit. Dave asked me if what I could do for you was to kind of just give you a little bit of insights of what's going on in manufacturing, connect some dots between the world of manufacturing, kind of what's going on from an economic standpoint, kind of political position, and then right on to technology that kind of connects the dots with MTConnect, you know, where it's all relevant. So before I start, I do have to do a couple qualifications. I do not have a PhD. My mother's just happy I got out with a BS from Syracuse, so no PhD. I've not written a book, unlike other people that we know, so I don't have that to my resume either. And I also did not work at Sun Microsystems, as some of the previous speakers have. So knowing all of that, I do know something about manufacturing, so I'll try taking you through a few things that hopefully you'll find helpful. I guarantee I won't take 45 minutes. And I also will talk fast, so I apologize to anybody who English is not your first language. My slides are available. You can have them later, no problem. You can translate them. So let's start out with some things, kind of a short-term and then a long-term perspective as to why manufacturing may be a good place to be. So if you're here, obviously you care about manufacturing. Is manufacturing a good place to be? Do you want to be doing this MTConnect stuff? Do you want to be in the middle of manufacturing? How does it look going forward? Well, actually, not too bad. If you look at some of the key statistics that are coming out, starting out with capacity utilization. Used to be that the capacity utilization kind of benchmark number you looked at was 80%. You know, if things were 80% utilized, it was really good news. People are going to be buying a lot of new equipment. It's very positive. Things are very robust. Actually, the new numbers these days, if you take a look at 75 is actually that peak point right now when you get to 75% utilization. And if you look at where the numbers are right now, it's at 79%. So we're over that 75% threshold, so it's a fantastic thing. Cash. This has been one of the most profitable times for manufacturing companies. Currently, manufacturing companies in the United States have $392 billion of cash held in reserve, often their piggy banks. And why that number is important is because when they start getting confident with what's going on in the economy and decide to pull that money out of the bank and put it into capital equipment and people in their plants, there's a lot more room left for manufacturing to have a continued robust future. So that's a really important number. Manufacturing, of course, represents 60% of our exports. Being fundamental to a strong economy is having a lot of export growth. So manufacturing sectors are the guys that are driving a lot of what's happening with exports. 60% of the exports coming out of the United States are coming from the manufacturing sector. And also important, that same kind of statistic, if you look at R&D investment. So the money being invested in R&D, manufacturers make up 67% of the United States investment in R&D. And obviously that's mission critical to innovation, innovation to commercialization, commercialization to the development of jobs and expansion of what we do with capitalizing them with support of our products and services. So it gets to be very important as well. And then just one more index, obviously the PMI, the Purchasing Managers Index, their benchmark number 50%. You know, better than 50%, that's a positive thing. Things are moving forward. Under 50%, they're starting to contract. Our current number, 54%. All good news. So you say, well, okay, those are great short-term numbers, kind of bigger picture. Can I get comfortable going out? Those numbers change every month. Give me a little bit better feel for going forward. Why should I be comfortable about manufacturing in the United States? Well, number one, the advances of things that are going on with automation. You know, is the United States going to be a good place to do business going on in the future? I'm worried about, you know, maybe I go to low-cost labor countries here, there, someplace else, and you know, I always worry about kind of this stuff leaving the shores here. And the points that I'm going to make are going to be true for any economy of these importance, but the United States happen to be particularly good at acceleration and advanced automation technologies. And that starts to level the playing field dramatically and takes somewhat labor out of the mix for most of the types of things that we're talking about in discrete component manufacturing. So huge opportunity in the United States to continue to accelerate with automation and actually level the playing field when it comes to those labor issues. That has already brought about and will continue to bring about a lot of what people talk about with reshoring. We've talked, Harry Mosier is one of the people recognize with this. There's actually a lot of people besides Harry doing this, and we're doing it before Harry started talking about it, but God bless Harry. You know, he's like a dog on the bone when you give him something, and he's got everybody right up to the President of the United States understanding what reshoring is. But the reason that it's important is because it's really going on. People are bringing this stuff back to the United States because of the point I had just before that, because you want to be close to your customer. Time to market's a major issue. People don't want the lag time. There's a shipping cost. There's energy costs we'll talk about in a second. I mean, all these things are big issues. That continues to go on. So that movement will keep going on. This is a really, really important one to take a look at, and I'll explain. It's kind of complicated looking, but essentially if you take a look at the middle one, US, comparing it to Europe and China, and start with the dark green hunk there at the bottom of ours, that's actually our oil and gas production. If you take a look at it compared to China, take a look at it compared to Europe, you can see the dark green there for the United States, dramatically more our production. Okay, the light green at the top is our consumption. So obviously we consume a lot, but look at the trend of our consumption compared to the trend of other people's consumption. Europe's tailed off a little bit, but China's going to keep on increasing, of course, as they get more and more and more. So they've got a real big problem going on there as to how they're going to actually meet that demand. We're in a really good position meeting our demand, and we're figuring out how to conserve. A lot of what you heard about people talking about things they're doing with MTConnect and talking about how they make it relative to energy and leveraging and maximizing the use of energy so they actually are minimizing it, maximizing how they figure out when to use it, okay? So that's helping. And then take a look, last two things on there, our gas and oil imports as a percent of overall consumption. Look where we are with gas. Negligible. We're not importing it. Oil keeps on going down as far as what we're importing compared to those other countries. So again, where's a good place to be doing business? Energy is an important part of it. We're in a good position. Got to have smart people. You don't have smart people, it's going to be really difficult to do things with manufacturing. And we happen to be blessed with some of the best universities, community colleges, anywhere around the world. People continue to come here for their education. One of our problems is we let too many of them leave again because we haven't figured out how to take care of H-1B visa issues. But separate from that, there's a lot of really bright people. You've heard a number of people here that are MIT graduates or are people here that have been to some of these universities. If you can produce the right talent, and that talent is based here, you've got a good possibility of being able to extend what you do for development of innovation and R&D. And at least we've got the breeding ground for doing that here. Next, it's very unusual to actually have the government actually do something that's focused on helping. I live near Washington. I don't tell people I live in Washington. I live in Northern Virginia. I try to actually distance myself as far as I can from being associated with Washington, D.C. I'm on the other side of the river. I'm actually from Rochester, New York, to be clear. I'm not from Washington. But it just so turns out I've been doing manufacturing my entire life, and there's been more positive things happening in the last 4 or 5 years in the current administration's time on manufacturing than I've ever seen in my entire life. And so there's a lot of focus on what can be done. The NAMI Center is a great example of how to start to try to do some of those things. Some of the coordination that's going on between the different agencies. We've had some talk. Fred that was here from NIST. The guys at NIST really focusing on things they can do to help coming up with great programs. And so when you take and Select USA is another thing they just recently put in place. Commerce set something up to say, hey, we have to work on the FDI, trying to figure out how we actually get foreign direct investment. How do we attract more people to put their factories in the United States, which is continuing to be a big thing. There's a lot of manufacturers that are here now in the United States. How do we get more and more of that to happen? So all of these things are actually really starting to position where you can see long-term, a lot of good, solid building blocks. They would say we're moving in the right direction. But then they have a lot of these people, again, other side of the river, trying to think about what are going to be the key things we should focus on. What are the core elements you got to have a sustainable, strong manufacturing economy? And I got a lot of brainiacs in a room. And they kind of decided, hey, these are the 3 things. We got to really have a strong STEM system. Education is important. Advanced technology. And you got to make it a competitive environment. You got to start dealing with the regulations, taxes, and other things. It's got to be a place where it's competitive to want to do business compared to any other place in the world. So they said those are the main things. So it's important to say, well, what are you doing then to try to make sure that keeps on happening, and how can you be involved in making that happen? Well, AMT has tried to take a lead position on that as well. We developed something called the Manufacturing Mandate. And any of you can download this from our website, amtonline.org. You'll find the mandate there. And it's a really helpful tool if you're ever talking to anybody, your congressmen, congresswomen, senators, about what are the important elements of manufacturing. It just so happens, you saw those 3 points that were on the slide before this. We developed this mandate back in 2009. So we had this out a bunch of years ago. And the 3 main points that we have in the mandate are surprisingly close to the magic ones that all those really smart people got in the room for a really long time and figured out we actually could just stolen a copy of the mandate and had this about 4 years before that. But anyway, they finally got there. And it's really these 3 key points. We try to make sure there's a focus on the people on Capitol Hill on the importance of innovation and R&D. And with each one of these, and again, I won't belabor you at this point going through it, there's legislation and programs attached to each one of these that can help accelerate those items. And so we try to provide enough detail for them so that they can actually make sure they get the right focus there. So whether it be on innovation and R&D or on global competitiveness, our ability to actually sell more easily in other places, level the playing field, make sure it's a fair place to be able to do business in other places, make sure this is the best place to do business in the United States. And the last point being smartforce. And we use that term because we really want people thinking that way. It's not really a workforce. When you take a look at the discussions, things are going on, robotics and automation, things like that, absolutely a lot of those old, direct labor positions on the assembly line are gone. People go, where is the turnaround in manufacturing? I'm not seeing the jobs. Just today, the new cover of Time magazine is all about manufacturing in the United States. But then the little byline down at the bottom is, and where are the jobs? Well, the fact is, those jobs that nobody really liked doing anyway, they're gone, and they're probably never coming back. The really good news is there's an entire array of new jobs that are higher tech, much more interesting, that people with some of those same base skills, leveraging a little bit of learning and some integration with data and information, are going to be able to actually drive a lot of the momentum forward in manufacturing. And we call that a smartforce issue, not a workforce issue. So I'm not going to, again, spend a ton of time on that. You can look that up at our manufacturing mandate, download, and have all the information you want about that. Those are just some of the key things. And I want to kind of slide out of that now and kind of go, well, okay, if that's what's going on economically, kind of short-term, long-term, and I kind of get some of those building block pieces that are happening as far as, what's the government going to do? What can we do with the government? Where are some of the key focuses? What's the path forward? What are those people who are really insightful saying, this is where we could be going, opening up an entire layer of creativity when it comes to manufacturing? And so, not that I didn't have anything to do and I just decided to cut out a bunch of quotes, but I'm going to bore you with about 6 quotes in a row here that just lay a little bit of the groundwork into some really interesting thinking as to where you might go with manufacturing. So first one, we'll credit to Jeff Immelt. Even though I know there's some GE people here, I'll just kind of preface the really cool things about this were all written by another guy, which I'll get to on the next slide. But why I start with Jeff is when you get the CEO and chairman of one of the most important manufacturing companies in the world talking about the importance of manufacturing, and from his perspective how he and a lot of others missed the boat and really kind of got into thinking that wasn't as critical, and now is rethinking that, and whether it's a plant in Schenectady, the plant in Erie, things that he's doing, there's a major refocus going on, and when it starts with people like Jeff Immelt, it's really important. So he is now getting that it is a competitive advantage. You heard Jim talking yesterday about what they're doing, obviously already with their engines and sensors, but not only just with their engines, they're actually talking about all of the equipment they put in their plants, having sensors and information to track what they do with all of their facilities. They're really making manufacturing a competitive advantage for them as a company, and in fact, his new bonus structure going forward is based on the additional value add they're getting out of their manufacturing facilities. That's part of what his bonus is based on. So that's putting your money where your mouth is. I think that's great. So we found another one. This is the guy that should get the credit for the stuff on the industrial internet that you hear Jeffrey Immelt talking about. This is the guy that actually wrote it. He's an editor at O'Reilly. And essentially, it's kind of the main cruxes could be caught here. You know, with a network connection and open interface. You know, highlighted, of course, that's the important thing for us. That masks all of the complexities and difficulties, that being the key. Machine becomes the web service ready to be coupled with software intelligence that can ingest a broad context and optimize an entire system of machines. I mean, it's kind of what we're talking about. What really starts to happen when you dig into the paper that, that John wrote, which was commissioned by GE, is really how you can leverage and use exactly what we're talking about. It really exists around this whole concept of open interface. And then being able to grab that data and do something with it. And so that's some of the thought providers that are really starting to get this sprinkled out. And this is getting picked up by a lot of different places. Another neat one. We talked about MIT, a lot of smart guys there. Neil is one of those. Neil's got another perspective when you start taking a look at, you know, when you move to something that we'll start calling, you know, cloud manufacturing. So you can say, I can foresee a worldwide system of fabrication labs that produce physical objects locally, but in fact are linked globally with information, enabling expertise to disseminate quickly. I mean, what he's really starting to do is get a lot of the people together at MIT and going, hey, I'm really seeing this whole context of what's happening with cloud computing really very quickly and easily assimilated into a concept for cloud manufacturing. I'll talk a little about it later, but again, one of the thought leaders in that area. Another really cool one. This is Mickey McManus. You can see some of his stuff on TED. He runs a company called Maya Design. He also wrote a book called Trillions. And this kind of, again, also just helps explain where's all the data information, how does this become so easy and common. And he's talking about, you know, when you can make transistors and as many of them as you can make grains of rice and actually make them cheaper than you can make a grain of rice. And you start thinking about having trillions of these transistors in everything, everywhere, being able to collect data and actually do some not analytics, but actually be able to do some processing of that. All of a sudden you start to imagine, and he even talks about the ability to print these, so essentially actually having printing, you know, through a printer or a transistor process, where now you just have these things are ubiquitous. They're just everywhere. And then all this stuff we started talking about with all this information, what are you going to do when transistors are on everything? So the whole Moore's Law thing, you just see continuing to exponentially increase as it becomes easier and easier to make a lot of these devices. Ken Ashton's the guy from the Internet of Things. He's the guy that gets credited with the Internet of Things. And what's really interesting there is, you know, again, how he talks about computers. From his perspective, they're engaged more in the process of doing the full development. So as you look at the quote, this reminds me of something that we saw yesterday. So he said, if we had computers that knew everything there was to know about things, using data they gathered without any help from us, we're not connected in the process at all, you know, then we would know all the things we would need to know to do lots of different repairs, replacements, improvements. And in Steve Fritzinger's presentation yesterday, when they went to those labs in Switzerland, and you saw those two robotic units, helicopters, figuring out how they could throw the device from one to the other, it's exactly what he's talking about. He's talking about not how they pre-programmed that in, but how the computers learned from each other, took the information they got from all that data, corrected and modified what they were doing to create a solution to allow that object to be thrown from one helicopter to the other seamlessly over a period of time. And it's exactly what Kevin's talking about here as well. And again, these are all things that just start opening up the perspective. These guys are going out, channeling this information, creating a lot of people following in behind what they're doing. Why is this all important? Because again, it all tied back into what we're trying to do with the changes that are happening in manufacturing. Last one. Chris Anderson. Chris, really sharp guy. Chris is the guy that's kind of behind all the TED presentations. He's a guy from Wired Magazine. He is, you know, kind of the key thinker behind all the TED presentations that go on. And TED's in the cloud, or in the crowd accelerated innovation, what we call open innovation. And essentially, he talks about global communities, being able to get all the people together, again, motivating, pulling their skills together, and what would happen, the innovation you could have if you could harness all those people, pull them together, working the same thing, how that boosts the overall talent pool in the world when you can figure out how to leverage them, share the information, and get them working on problems you want to solve. So all 6 of those folks are really starting to drive some really neat things that are happening. And we think they drive into things that we watch pretty closely at AMT. three main drivers that we think have a really important impact on where manufacturing is going that we see part of what we're doing today and a really important part of where we're going tomorrow. So mass customization, open innovation, or what Chris talked about is crowd-accelerated innovation, and cloud manufacturing. So a couple quick points on each. Mass customization really gets to be a lot easier now when you put together these key components. So people have talked a ton about 3D printing, additive manufacturing. It gets to be, obviously, a very important part of mass customization. Mass customization, the ability to make millions, hundreds of thousands, tens of thousands of components for the same price as you would be building them at if you're doing large quantity, but you want to do one-offs. So one-off specialization, kind of at the price and performance of building as if I was building hundreds of thousands of those components. When you have additive manufacturing, it's a good way to do it when it starts getting to be more net shape, final net shape. You've got other ways to do it. If you look at multi-axis, multitasking, multifunction machining centers, you all of a sudden get to the ability to do rapid changes and have multiple processes within single clampings of parts where you can program in modifications part to part to part to part without a lot of extra fixturing and tooling to accomplish the means to the end. Automation also tied into the process, allowing to very flexibly be able to understand what's going on from one part to another, changing from one to another, very quickly, very seamlessly. So the ability today to integrate down a seamless road of mass customization is a lot easier now because you've got the main elements. Everything including the automation, which used to have a lot of this stuff before, but you'd go, well, first of all, the automation wasn't as reliable. Now it's a lot more reliable. There's a lot more information coming out of the system. You've had 3D around for 20 years, but 3D now is getting much more stable as a manufacturing process. And you're really just starting now to get to very efficient multitasking, multifunction. Multitasking, milling, drilling, same kind of metal removal. Multifunction being where you're actually doing things like machining and grinding, or machining, measuring, machining, cleaning, machining, marking, broaching, all in the same process, multi-functions. So a key part of mass customization. And you start looking at that being accelerated going forward, say, what if the process of actually making some of those parts that used to be just done 3D printing or epoxy resins or plastics happen to be metal parts? What happens if those metal parts actually get to be net shape, not near net shape? So right now they come out near net shape. And people keep going, just don't see it happening. And I got to tell you, it's definitely going to be happening. If you don't think it's going to have some impact on your business, you're crazy. So there will be net shape parts that are going to be out for a lot of applications. And then you start to go a little bit further than that, and you kind of go, well, what was going on relative to some of this 3D things? That bottom left-hand corner there is some work that Skylar Tibbetts is doing, another really smart guy from MIT. MIT's got a lot of smart people hanging around. And Skylar's tried to figure out how you could take the 3D process and switch it and make it 4D. Make it 4D how? Make it 4D by thinking about, what if you actually built the 3D process of the components you're putting together and thought of it more like DNA gets built in the body? Where you actually, he's kind of moving to biomanufacturing, where you would actually have things that are smart individual elements when put together could learn from one another and know what's going on so they could self-build themselves. He calls it self-assembly. And these are some of the things that he's done with bias chains, who's actually pre-programmed some things in. So depending on how much motion you put on them, they take different configuration and shapes based on what he's pre-programmed into the individual elements before you created them in a 3D process. So really neat things happening, which starts moving in an entire field of biomanufacturing and self-assembly, which even when you think you start to get 3D down pat, here's somebody coming up with a concept for 4D. And that goofy little thing and you see in the other corner going, so what up with that? That's a company called Romotive. Romotive is a bunch of guys got together and said, you know what? I think there's some other neat, cool things you could do with robotics. What if I could take my cell phone? What if I could take my iPhone and actually put it on a little platform and actually create a very simple interface where I can use all the information that's already there. I already got a phone, Siri's on it. I can talk to the phone until I want to do drive forward, move backward, do this and that. So make a connection to a platform using the information that's already in the iPhone and have a device that can go do things. I can tell it what to go do, where to go do something, pick something up, and actually put a lot of personalized, human-like features into that robot. So it seems very Mickey Mouse kind of kid-like, but what it's actually starting is there's this entire world out there of people going, how do I take very simple things that are already out there existing, connect them together some interesting ways with what I know about controls or software, vision systems, anything else, and actually create some solutions, and the people out of the norm. So this isn't Fanuc doing it. It's not KUKA doing it. You know, these are people just kind of going, hey, I got some better ways to put motion and control together to actually create something that would be useful. And those movements are driving really neat things that are happening in technology. And those robots and those other systems make the whole mass customization process a lot easier in the long run. Open innovation. You know, some obvious ones, you know, at IMTS, here at IMTS, you saw the locomotives one. You know, first car company startup in the United States in a long time, besides the one the government funded for doing things with batteries, which we won't get into those. These guys actually have a very successful business that they've created. And they do it by leveraging the intelligence of everybody in the world to do it. So they come up with ideas for little contests, for designs for their car. Those go out to engineers around the world. Those people send in information. And from that, they actually design cars using the global intelligence of everybody that wants to participate in their open innovation centers. And then they assemble these things in Chandler, Arizona. And they've been extremely successful doing it. And it's not just there. GitHub, same concept when it comes to software. How do you leverage brains from all over the world to go solve things and then make a lot of what's there open and available for other people to leverage and use pieces of? Locomotors, the stuff that they put out there, if you give them a design for something that they're going to use anywhere in the car, it's open and available for other people to go use. If you want to participate, that's part of the game. Same thing, obviously, in a lot of what happens with GitHub. And Incentive is a company that started up just to do that for people. So they're an accelerating vehicle if you wanted to do your own. So you want to do your own locomotive thing. You've got a problem, you want to solve it. You come up with how much you'd want to have for the challenge, 5,000, 10,000, 20,000, what exactly it is. And then they figure out how to pull off that challenge for you. They'll set it up. They'll go out to the right mix of people anywhere in the world, help solve a problem for you by doing crowdsourcing or open innovation. And that's also kind of back to MTConnect. And our challenge.gov is a version of where we got the MTConnect challenge based out of. The government leveraging the whole concept as well. How do you go leverage all these people? So open innovation is really going to change how we drive the things that we do. And again, all of it's going to drive back to information and data and commonality of that. Cloud manufacturing, last one that I'll get into. So cloud manufacturing, and I know, again, you're going to look kind of after low motive, is going low motive and robots. This guy doesn't get much about technology and automation. Now they're looking at the side, just going Child's Own Studio. Whoa, this guy's really losing it. All right, so I asked my staff, come up with some interesting things for some pictures for my presentation on cloud manufacturing. They came up with that. And I first was going to say, guys, it's pretty, it's nice, can't have it. But actually, it was kind of interesting to use kind of in a parallel here. So this is a person that decided to start a company and said, if you want to start with, you can see the little crayoned pictures. So your kid comes up with a crayon picture. And essentially, this person had an idea going, what if I could take those crayon pictures and actually take that design then, figure out how to design into a model of some type, and then take that model and actually fabricate a kid's toy. I'll make the kid's toy exactly like what your kid drew. So it's mass customization. Everyone is different. Made to your specifications and your needs. And all done somewhat virally. You don't go there. You send the information to her. She figures out in her facility and studio how to go create it, and she creates those toys. And she's got a real nice business doing it. She's getting all kinds of advice now from, like, you know, that's a TV show with sharks or whatever, you know, all these things going, you should do this, you should do that. And she basically says, look, I don't do that. I'm as busy as I need to be. I'm happy as a clam doing this. I don't want a $500 million company doing this. This is working out just great for me. Cool concept of what you can do. Segue to manufacturing, Shapeways. Same exact idea fundamentally, but these guys have a lot of additive manufacturing capability. So these guys acquired some of the coolest additive manufacturing equipment, put it in their facility, and essentially said, look, whatever idea you've got, whatever part you have, if you're actually trying to do jewelry, things like that, that's fine. Or if you actually have an automotive part, an aerospace part, if you've got a design and you want it made, and you don't know how to get it made, you want to send it to us, we'll make it for you. So Shapeways has set up an entire business so that they can be a rapid turnaround source for you to be able to make anything. Just you send them the information, they create the part, it goes back to you, and they're figuring out how do they accelerate that into becoming a design shop, manufacturing shop, and they're actually not just doing additive. Start to get into other types of technology that they could do that for you and actually leverage equipment that's not just their equipment. Which in my mind gets to be the next really cool thing to think about, which a lot of people just have a difficult time putting their head around, but it's really going to happen. So if you think about the whole concept of what happened with Amazon and cloud computing. So here are guys that basically sold books. So the really busy time was end of the year, Thanksgiving to Christmas, and so they had tons of servers. They had to gear up to be able to handle all that stuff that would come to them at the end of the year. And then they realized the rest of the year, all that capacity sat there. And they're going, well, this really stinks. Put all this money into capital equipment, and the capital equipment just sits there. Doesn't get hardly any use for most of the rest of the year. We got to find something to do. They're like, well, couldn't we sell some of that capacity to other people that need storage or need to use the processing power? Yeah, I can find a way to do that magically. Okay, Amazon Web Services. These guys have become huge, obviously, doing that. So you're going, okay, interesting concept. Cloud manufacturing, I get it. Saw the toy thing. Yeah, it's kind of shapeways there. I'm getting a little bit, but where's it really going? Well, you start to think about all of people's capital investments. And what about if you took the same exact concept? So people have equipment on their floor. You're not utilizing it 24/7. You wish you were, but you're probably not. Nearly impossible. What if there was a way you actually, just like their capacity, you could figure out where there's capacity anywhere? With things like MTConnect, you're collecting enough information about the process and the equipment. You know very specific signatures of different pieces of equipment. And you could actually have a network of knowing where all these nodes are, like these guys are talking about with the Internet of Things. A lot of these other concepts when we talk about the 6 guys that had interesting ideas of where the paths are going. What about if you could actually have a connected system where you knew where all that capacity was? And that you could actually get time to get on that capacity to solve what you needed. And what you needed was something being manufactured out of steel or other things that are readily available from a lot of different places. So that you could actually then utilize that spare capacity to do exactly what Amazon's done using their servers, and now actually not just using their servers, using a lot of different servers that they get space on, and actually giving it back out to you to use it very small cents on the dollar to actually get what you want. It's going to happen in manufacturing as well. People are going to figure out how they connect the capacity of equipment that they're not using readily and allow people who are out there, again, whether it's the kid with the drawing that just wants to have their doll made, or it's the shapeways thing where I've got my little 3D design and I just want my little part made out of additive, or they have a relatively complex aerospace part. Monoblock would be best, machining it from a solid, but someday getting a casting sent to them, whatever. If you're going to have it UPS'd or sent to your place from someplace, it could be sent to the place where the capacity is available, and the stuff gets made for you. And it's going to be happening, and you need to think about how does that impact what you do with the business. And when we look at all these things, what really becomes clear to us, because all of these things are steps that are already in place in these directions. These people that came up with these ideas have already put a lot out there. There are thousands and thousands and thousands of people doing these things that we're talking about. It's not like, that might be interesting. I can also tell you the Department of Defense on this idea of cloud manufacturing is putting millions, tens of millions of dollars into this, figuring out how to make that work. It's going to happen. And it's important to figure out how you leverage this yourself. So last quote, and I'll wrap up. So again, going back to John, the industrial internet refers to machines becoming nodes on pervasive networks that use open protocols. All this stuff, tying these pieces together, always keeps coming back around the same exact thing to make it work. To make it work at the end of the day, everything comes back around to you've got to have the open interoperability standard to make it all work. So you've heard a lot of great presenters, talk this week. You've been to a lot of sessions. It's amazing how far MTConnect has come. And the important, I guess, leave behind or takeaway that I can give you now as we wrap up is the concept that Chris Anderson talks about when he talks about, crowd-accelerated innovation is really where we're at. You guys are the crowd accelerators. Okay, your ability to talk to one person, 2 people, put it into a spec, help develop some bit of the open source code, get somebody else involved with the project, push it upon an OEM. These are the things that are starting to have a really dramatic effect on the whole crowd acceleration of this innovation. What's happened in the years, we talked about it from when John Bird started it, back at the beginning to where we're at today, it's been unbelievable. And we're just at the point of really having even more dramatic things. When you talk about the challenge, think about the Department of Defense getting through this challenge and ending up with a lot of great ideas as to how they would use MTConnect, but having a real application which takes away anyone's excuse for why they're not using it. And then imagine the Department of Defense saying, if you want to do any business with us, you must be MTConnect compliant. What does that do to the industry? What if GE would start to say, if you want to put anything into our plants because we want to track everything, you want to sell anything to GE, it needs to be MTConnect compliant. You're right at the edge of that for a lot of different places. So hopefully we've been able to do a little bit here to help you do a little crowd acceleration, learn a couple different things. Hopefully I gave you a little perspective of what's happening in the world of manufacturing. And as promised, I got done in less than 45 minutes, so I'm giving it back to Dave. Thank you.